Good morning, students. In this video we shall study about three topics in the chapter sound. The first one is loudness, the second one is pitch, and the third one is monotone. Let's see the first topic, that is loudness. So loudness is nothing but it is a characteristic of a sound by whose virtue we can just distinguish whether the sound is faint, that is a sound is low, or sound is high. It depends upon the amplitude. Now you can see in this diagram, that is the graph which is given, both the graphs, you can see both the graphs. In the first graph the amplitude is small, it is going till 2, and in the second graph you can see the amplitude is going till 4. That is, the amplitude which is small is having faint voice or soft sound is heard, and where the amplitude is more, the sound which is heard is louder. Now we have some examples related to it, and the first one is to play the guitar or sitar. If you just touch the string, it will just ring slowly, but if you play it hard, it will more sound will be heard. The next one is the example of drum. If you just beat it gently, a faint sound will be heard, but if you just beat it loudly by taking the stick farther and then beating to the drum, loud noise will be heard. The next example is tuning fork. The next one is piano. All these examples shows about the loudness of the sound, how the sound is heard. In this diagram also you can see two type of things are used to produce sound. The one is a stick and the another one is pencil. With pencil, faint sound will be heard, and with stick, loud sound will be heard. The next is the factors which affect the loudness of the sound. The first factor is the amplitude, and this we can understand with the activity. The activity is take a drum and place a ping pong ball on the membrane of the drum. Beat the membrane gently with the drumstick. A feeble sound will be heard, and the ball moves up to a small height and down, showing the amplitude of vibration is small. Now beat the membrane harder with the drumstick. The drum produces louder sound. The ball jumps higher, showing the amplitude has increased. Now what they have done, you must have seen a ping pong ball. What they have done, they have just beaten the drum with a stick slowly in the first time, and then the ping pong ball is placed on that, which shows the amplitude of it, how high the ball is going. And after that the drum is beaten harder. After that the ping pong ball was going high, it shows the amplitude has risen up. And the next one is the distance of the source of the sound, how much far the distance is, because if you are near to some sound, more sound will be heard, and if you are farther from some sound, less sound will be heard. So if you can see this boy placing his ears attached to the table close to the alarm clock, so more sound will be heard. But if the boy is placing his ears attached to the table but the clock is far away, less sound will be heard. So in this way you can see that the sound which is heard is low. The sound which is heard will be low, and the sound here will be more than the previous one. The next one is the surface area of the vibrating body. What type of surface is taken? The large vibrating area sends forth a greater amount of energy, so amplitude of vibration is large, hence the surface area of the vibrating body louder sound is heard. It means if more of the surface area is covered, more sound will be heard, and less surface area is covered, less sound will be heard. They have again taken one example. Take two drums, one is small and the other one, take bigger one, and then beat them one by one to produce vibration in them. You will notice that the sound produced in big drum is louder than the small drum. So we can conclude that loudness depends upon amplitude of vibration. More will be the amplitude, more will be the vibration. On the distance of the source of the sound, that is how close the source of sound is. And the next one is the surface area which is used. A smaller surface area will produce less sound, more surface area will produce more sound. The next is the relationship between loudness and the amplitude of wave. So there is a direct relation to it, that is loudness is directly proportional to amplitude square. They have also shown by taking numbers, and then they have shown with the help of graphs. You can see it is clearly given in your book. Two waves of different amplitudes are given over here and how they are related to it. So in B part it is going till 3, and in C part it is going till 2. So we just square that and we got the square of both, that is the square of 3 and the square of 2, that is 4. So loudness is a square of amplitude, is directly proportional to the amplitude square. Next one is the unit of loudness. The unit of loudness is decibel. The next topic is pitch. Now pitch is the characteristic of sound that differentiate an acute or shrill sound from flat sound. Shriller sound, you can say, student, shriller sound here means the sound which hurts the ear, or the sound which irritates you. For example, sound of a very thin loud sound are called shriller sound. And for example, you can say humming of bee and all that. These are, if they are humming together, so the pitch will be high, so it will be very shriller and irritating to ears. So it is what it is differentiates an acute or shrill sound from flat sound. Flat sound can be loud, but flat sound never hurts the ear. So this is what they mean to pitch. Now again, you can see that here two graphs are shown, and with this we can explain the topic, that pitch of a note depends on its frequency, and we have already understood what is frequency. Now two notes sounded on the same instrument with same amplitude will differ in pitch when vibrations are of different frequencies. Now in figure 7.9, two waves of different pitch are taken, A and B, each of amplitude 2. The wave A is of time period 1, so the frequency is 1 upon the time period, so it will be 1 upon 1, that is 1 second inverse. And here the wave in wave B, the time period is 0.5 seconds, so frequency will be 1 upon time period, so it will be 1 upon 0.5 seconds, which is 2 seconds. So you can see in the second one the time period was less, so frequency was more, because they are inversely proportional to each other, and so the pitch is high in the second wave. So you can see wave A is of low pitch while wave B is of high pitch. The next is the example of sound of a examples which we can give for pitches: frequency of sound of a crying baby and a frequency of crying of a adult person. The next one is of postcard is rubbed slowly against the teeth of a comb, a grave sound is heard, but if it is rubbed faster, a shrill sound is heard. So these are the examples which you have to read it by yourself. It's nothing, it's just the recap of previous topics. Then some instruments are given here, which are the examples of pitch. And some instruments in a string, there are some string instruments and some wind instruments which you have to read by yourself. Give how many instruments are stringed instruments and how many instruments are wind instruments by which it is blown. For example, wind instruments are flute, by how it runs. It runs when we blow air into it. So bugle, flute and shehnai, all these are wind instruments. And in string instruments are sarangi, guitar and piano. These are string instruments in which there is a string and we have to just use that string to play that. These are the activities which you have to read by yourself. Activity 4, 5 and 6. The next is the membrane instrument. Membrane means having a covering. So they are drum and tabla and dholak. Dholak is also the example of it. The next one is monotone. So monotone is a sound of a single frequency is called monotone. Mono means one. So a sound of single frequency is called monotone. A tuning fork is the only source of sound which produces sound of a single frequency. So here is the example given of a monotone. You can see the tuning fork. These are the prongs which strikes together and the sound is heard. This is the graph which is shown of this tuning fork. The next one is the quality of the sound. Quality is the characteristics which distinguishes two sounds of the same pitch and same loudness. What type of quality the sound is having, it is being judged in this. What type of pitch it is having, what type of loudness it is having, this is judged in the quality of sound. The sound produced by any musical instrument or human beings contains a small amplitude or two waves of different frequencies which are integer multipliers of a frequency of source. Here is the waveform in which here is the graph is given in which waveform of a tuning fork is given, which is a monotone, and waveform of a piano is given, which is a string instrument, whose graph is given over here. Now the last one is the making of a musical toy, which you have to read it by yourself.